Hello, I'm Pavan from Kausalya classes. In today's lecture, we are going to discuss Introduction to Physics Part 2. In Part 1, we have gone through the idea of what is physics, idea of a relationship between physics and mathematics, units, who decide unit, that's CGPM, fundamental and derived quantities, the quantity which are independent of each other, and all the other quantities are derived based on these fundamental quantities. Fundamental quantities are also called base quantities. We discussed SI units, SI prefixes, and some definitions like meter, kg, second, ampere, Kelvin, and mole. Now, in today's lecture, our concern and our topic is dimension. When a physical quantity is expressed in terms of base quantity, it is written as a product of different power of the base quantity. For example, if I'm talking about force, force can be written as mass time acceleration, but mass can be written as velocity upon time. But velocity can also write displacement upon time. So overall, force can be, we can write force as mass into displacement upon time to the power 2. We know the displacement is a length. So if we want to deduce the base quantity which is involved in derived quantity of force, as we know that force is a derived quantity because to make or to express force, three base quantities are involved, and that base quantities are mass from here, length from displacement, and time to the power minus 2. So as I told you, when a quantity is expressed in terms of base quantities, it is written as product of different power of base quantity. And now we can read it as the dimension of force are 1 in mass, 1 in mass, 1 in length, minus 2 in time. One important point here we should note that the dimension in all other base quantity are 0. If you are talking about force, then dimension of m is 1, L is 1, and T is minus 2. But all other dimensions, all other base quantity like temperature, electric current, amount of substance, luminous intensity will be 0. And for our convenience, we write the base quantity with some symbol. For example, for mass, we can write capital M. For length, we can write capital L. For time, we can write capital T. For temperature, we can write capital L. For current, electric current, we can write capital I. For mole, we can write MOL. For luminous intensity, we can write CD, and so on. So a physical quantity in terms of base quantity is called dimensional formula. Means this is a dimensional formula of force. Now in that way you can deduce other dimensional formula for other derived physical quantity. If you want to derive a dimensional formula for energy, as you know, energy is nothing but the work done, and work done is force time displacement. And as you have already formulate the dimensional formula of force, you can write it directly m1 L1 T to the power minus 2 times L. Yeah, we are enclosing the dimensional formula with the square bracket. So the dimensional formula of energy will be m power 1, L power 2 and T power minus 2. Now our next concept is what is the use of dimension? Means topic is uses of dimension. First and very important use of dimension, it is gonna help us to find whether the given expression is dimensionally correct or the given expression is correct or not. How? It is a very important concept now we are going to discuss, and the topic is, or this topic is under uses of dimension, and the first use is homogeneity of dimension in an equation. Homogeneity of dimension in an equation. In an equation. Homogeneity of dimension in an equation. See, it is not possible to add or subtract two different physical quantity. It is difficult to subtract 5 seconds from 5 kg. This is not possible. So if I have written S is equal to ut plus half at square, that means if this is a length, then this must be length and this must be a length only. Otherwise we cannot get this length while adding other than length as a base quantity. Means we should prove with the help of dimension that this quantity ut is length only. We already know that ut is nothing but the length. How? Because u is initial velocity, and velocity, dimension of velocity is L t to the power minus 1, and t is t to the power 1. So that t to the power minus 1 and t to the power 1 will get cancelled. Ut is L itself. And if we are going to talk about at, one more thing. Dimension of constant value is 0. Dimension of a constant value is 0. Dimensional formula for a constant is 0, or we are not considering constant in dimensional formula. So the rest part is at square. We know that a is distance upon time square. So time square and time square will get cancelled and distance can be measured with L. So hence proved, this formula S is equal to ut plus half at square is dimensionally correct. But we should keep one thing in our mind, that we are not considering constant in dimension. So if we will write S is equal to ut plus at square, this will be also correct. So at this stage there is some limitation of this method, and this method says if a dimensionally correct equation, if you have a dimensionally correct equation, it need not be actually correct, but dimensionally wrong equation must be wrong. Okay. So if we are having some another for example, if we have an expression t is equal to 2 pi under root m upon f upon x. Here m is mass, f is force, x is distance. So let's check whether this expression is dimensionally correct or not. So we are not going to consider constant in dimension. So we should write m for mass, or m to the power 1, L to the power 1 and t to the power minus 2 for force, upon L for this x. L will get cancelled, m will get cancelled, under root t to the power 1 upon t to the power minus 2, means that is equal to under root t to the power 2. Under root n square will get cancelled, it will become t. So see, on right hand side we are getting t, on left hand side we are having t. So this expression, this given expression is dimensionally correct. So this expression may be correct. Okay, so with the help of dimension we can check whether the given expression is dimensionally correct or not, and this is what called homogeneity of dimension in an equation. Means we can add or subtract same type of base quantity or fundamental quantity. The second importance or second use of dimension formula which is there in our course is conversion. Conversion of units. How we are going to do the conversions and why we want to do that. In so many numericals you will find that the given value is in CGS system and we must have to convert them in SI unit because whatever the expression we are having are framed on the basis of SI unit, so we must have to convert the given value into the SI unit. So for example, let's take pressure, and we know that the pressure is equal to force upon area, and we know the dimension of force is actually, our intention is to find out the dimension of pressure. So pressure is equal to force upon area, and dimension of force is ml to the power 1, m to the power 1, l to the power 1, and t to the power minus 2 upon area is length into length, so it will be length to the power 2. So dimensional formula of pressure will be m L to the power minus 1, T to the power minus 2. With the help of this dimensional formula of pressure, it is going to help us to convert the SI unit of pressure, or we can make a relationship between SI unit and CGS unit. We know that SI unit of pressure is Pascal, so 1 Pascal upon 1 CGS pressure is equal to 1 Pascal means m to the power 1, l to the power minus 1, t to the power minus 2 upon m to the power 1, l to the power minus 1, t to the power minus 2. Because whatever the value is expressed, whether it is expressed in SI unit or CGS unit, the physical quantity will pressure itself. So in SI unit, mass we are taking in kg, so kg to the power 1, or in length we are taking meter, so 1 meter to the power minus 1. Time is in second, so second to the power minus 2. In CGS, mass is taken in grams, so 1 gram to the power 1. 1 centimeter to the power minus 1 and 1 second to the power minus 2. We are going to deduce and reduce these values. 1 second to the power minus 2, 1 second to the power minus 2 will get cancelled, and we want to equate the unit, so it's very easy. 10 to the power 3 gram to the power 1, and here we can write 10 to the power 2 centimeter to the power minus 1. Now what will happen? This 1 gram and 1 gram will get cancelled. This 1 centimeter and this 1 centimeter will get cancelled. We will have only numerical value, and that numerical value will be 10 to the power 3 into 10 to the power minus 2. So it will be equal to 10. So we can write now with this expression we can say that 1 Pascal is equal to 10 times CGS pressure. 10 times CGS pressure. So as I told you, this is the second use. You can say that we can convert the unit with the help of dimension, and in first point we did homogeneity, through which we checked whether the given expression is dimensionally correct or not. The another use of dimension is deducing relation among the physical quantity. Deducing relation among the physical quantities. How? Let's see if we are smart enough to make guesses. Let us suppose we are having a bob which is attached with the ceiling, and this bob is having mass m, and we just plug these on this bob into this direction, and it will go here because the length of the bob is fixed. So once we are going to apply a force in this direction, the bob will start rising, and once we are going to release it, it is going to swim in this direction and it will reach up to here, and we are saying this will become pendulum. So let's suppose I want to find out the time period. My interest is to find out the time duration in which this pendulum is repeating its path. Means how much time it will take to go there and come back and go in this direction and come back. This 4 part will become one complete oscillation or a revolution, you can say, and we are interested to find out the time period. So let's suppose time period. Let's suppose I'm writing time period in t, and let us suppose I'm smart enough to make guesses. Let me predict and let me make some guesses that I think this time period depend upon this length, as well as the mass of the bob, as well as because acceleration due to gravity is already applied in downward direction, so it will depend upon this acceleration due to gravity also. And we are just neglecting the other factors like air present around the bob and all these condition, temperature and pressure. So these three physical quantity, I guess that may affect the time period of the pendulum, and these physical quantities are length, mass and acceleration due to gravity. So let us suppose this time period is depend upon length, and we actually don't know how it is related. So I want to make some power, I want to write some power over length. Let us suppose L to the power A and M to the power B and G to the power C. But I know if I want to deduce these physical quantity into base quantity, this will become L to the power A, M to the power B and L T to the power minus 2 to the power C, because L upon T square is acceleration. So I just wrote this dimensional formula in place of this physical quantity of G. So if I want to remove this proportionality sign, one proportionality will come into the picture, and that is, let us suppose, K. So T is equal to K times L to the power A, M to the power B, L to the power C, T to the power minus 2C. If I want to express it in a simplest way, you can write L to the power A and L to the power C. So by the help of indices, you can write, you have already gone through this concept in previous classes, that if A to the power M into A to the power N, this will give A to the power M plus N. By that logic, T is equal to K times L to the power A plus C, M to the power B and T to the power minus 2C. And on left hand side, you can see this is time. So in place of time, you can say T to the power 1. So, or you can say, if you want to write the expression with the expression of fundamental quantity, you can write M to the power 0, L to the power 0 and 2 T to the power 1 on left hand side to show the dimensional formula of time. So dimensional formula of time is what? M to the power 0, L to the power 0 and T to the power 1. Why I am writing this expression? I am writing this expression so that I can relate or compare the parts of left hand side and right hand side, because on right hand side The another value is k, constant value is k, which is not going to involve in dimensional analysis. So by the comparison you can see the a plus c is 0, b is 0 and c is equal to minus 1 upon 2. Right? Once you're going to put this value in this value, you will get a is equal to 1 by 1 upon 2. So now we know how the length, mass and acceleration due to gravity is related with time period. So time period is equal to k times L to the power 1 upon 2, m to the power 0 and g to the power minus 1 upon 2. M to the power 0 says that mass is not involved and mass is not making any effect on time period, so it will be, it is not going to be there in the expression. So time period capital T can be written as k times under root L upon z. So see, by the help of dimensional formula, we have deduced the relation amongst the physical quantity. But here we have few limitations, means we cannot deduce all the relations by this logic because it had some limitation. If you want to discuss about the limitation of the dimensional method, so it will be like limitation of the dimensional method. The first and very important problem with this dimensional method to deduce the relation is uh, all the dependent physical quantities. In the last problem we discussed about the time period, which was k times under root L upon g. So the problem with this dimensional method to deduce the relation is all the dependent, here the dependent physical quantities is L and G. So all the physical quantity who depends should be in multiplication form. This is the first problem. But it means that you cannot deduce S is equal to ut plus half at square with this logic. The second problem is it is not taking care of the constant. Means we are not able to find the value of k. You know that the k is 2 pi. When you will go through the physics course, you will get this value. But by the help of dimensional method, you will not get the constant value because dimension is not taking care of the constant value. And third, as you know, it is generating a lot of variables that in this previous cases, means in case of time period, the variable was a, b, c. So if you want to find out the value of ABCD, you have three equations. The last time we were having three equation, that was a plus c is equal to 0, b is equal to 0, minus 2c is equal to 1. So to find out the three variable, you need to have three different equations. So this is not always possible because see, so many other factors are also affecting a particular physical law which is governed by the nature. So it is very difficult to understand in that way. Now our next topic is order of magnitude. Order of magnitude. Why it is important? It is important because we are going to deal the mass of earth, mass of universe, mass of electrons. So we are having a wide range of physical quantity which we need to express numerically. So it is a good idea if you are going to write it in this logic in scientific notation if you are using. So you should write all the value in this form, a into 10 to the power v, where the value of a should be greater than or equal to 1 but less than 10, or v should be integer. So you are already using this kind of notation. Like if you want to express the charge, so what you will write, it will be the charge on electron is minus 1.6 into 10 to the power minus 19 coulomb. So I told you that this A should be greater than or equal to 1, but you can claim this is a negative value. No, this is not a negative value. This negative sign indicate that this is a negative charge. The magnitude, this A value is 1.6 itself. So this is one important point I wanted to discuss with you. Now the next topic is structure of world. Structure of world. See, after extensive experiment or after extensive experimental work, people arrived at a conclusion that the world is made up of just three type of ultimate particle. You have already aware with these particle with the name proton, neutron and electron, right? Proton having positive charge, electron with the negative charge, and neutron having no charge, right? And neutron and protons are there in the nucleus and electrons are evolving around it. This kind of concept and Dalton atomic theory and J.J. Thomson and you can say Rutherford experiment, Faraday concept, all these concepts you have already gone through in your previous classes, structure of atom in ninth class. So in physics, you can say the structure of world is not so easy. So the large number of atoms combine to form an object of molecule or a large size. So however, the law that we generally deduce for these macroscopic objects are not always applicable to atom, molecule and nucleus or elementary particles. Means whatever the rules you are going to frame for a bigger particle is not going to apply on a smaller particle. So if we are talking about the macroscopic level of concept, it is called classical physics. It is called classical, sorry, classical physics. In classical physics, we are dealing the large size of object. But in microscopic level, in 20th century, the experiment have revealed another aspects of the construction of the world in which there are perhaps no ultimate individual particles, thousands of elementary particles, have been discovered, and I think in nowadays it is more than that, and there are free transformation from one such particle to the other. So nature is seen to be well connected entities. So if you will talk about the structure of world, it is not so easy. So rest of the part we are going to discuss in the next lecture. We will going to start the new topic, and that is physics and mathematics. We are going to discuss in physics and mathematics some basic tools, some basic mathematics which is going to use in physics. Till then, bye bye, take care. Thank you.